day 2 of optimization. We are on daily lessons 153 and 154. You can do this. I'm actually not going to start at example 5. I'm going to do something wild and crazy and start at example 6. The reason is, example 5, you can get hung up on the algebra. There's more room up here, you can see. Example 6 just kind of gets us back into this, reminds you what optimization is. So in example 6, it says the profit P in thousands of dollars for a company is spending an amount S in thousands of dollars on advertising, and then you have this equation given to you. Find the amount of money the company should spend on advertising in order to yield a maximum profit. So in all of these problems, you're trying to find a maximum or a minimum of something. And then whatever this is asking for here, so a maximum profit, it means you need to take the derivative of the profit function. In this case, the profit function is this, the negative 1/10 s cubed plus 6x s squared plus 400. And at this point, this is where I see, are there any constraints in the problem that I can use to simplify this in any way? Got good news and bad news. The bad news is this is not really a traditional optimization problem because this is already solved for, like, I just have a p over here, which I can take the derivative of and get p prime. Over here it's all in terms of s, so I could always take the derivative in terms with respect to s. So we're good. Right now, I just have to find the derivative, find those zeros, and figure out where is a maximum happening. So if I take the derivative, p prime, I would get negative 3/10 s squared plus 12s plus 0. So the derivative of 400 is just 0. And then I set this equal to 0. This is where I have an s squared here and an s here. I can factor out an s. I know one of my zeros would just be where s is equal to 0, but I don't think that I want to spend $0 on advertising and I can't spend negative. So this s is equal to 0, not that important. This I can also set equal to 0, so negative 3/10 s plus 12 equal to 0. Subtract, get negative 3/10 s is equal to negative 12. I don't know why I'm just using the bottom of this page when really I have plenty of room, but I'm still going to do this because I committed. Negative 10/3 multiplying both sides. 12 divided by 3 is 4, times 10 is 40, negative, negative, positive 40. So I need s is equal to 40. And I have to think about, what does that mean? So s is equal to 40. This is saying find the amount of money the company should be spending on advertising. This is my only answer right now, so most likely will be a maximum, but let's just check to make sure. Going 0 p prime, and I want my derivative to change from positive to negative if I have a maximum. But let's check. I'm going to go 0 to 40, 40, 40 to infinity. I know at 40, when s was 40, p prime was 0. And then I want to say, okay, well, 0 to 40, I'm going to substitute in my favorite number. My favorite number from 0 to 40 is 3, but I'm going to substitute in 1 just because that's usually a little bit easier. Negative 3/10 but plus 12 will be positive. Positive times this will be a positive 1, positive. 40 to infinity. If I put in something like, I don't know, 5 million, negative 3/10 times 5 million plus 12 is going to be negative, because this negative 3/10 times 5 million is going to be huge. 12 is not really going to matter. Times a positive 5 million. Negative times positive is negative. That means P, the profit, has a maximum as P will change from increasing to decreasing. And so now I just have to answer the question. It says find the amount of money the company should spend on advertising in order to yield a maximum profit. And you're like, yeah, 40. That doesn't make any sense. You don't want to spend $40 unless you're a teeny tiny company, and this is talking about a teeny tiny company that is going to be like advertising for a lemonade stand or something. Maybe then it's $40, but this one is in thousands of dollars. Now my answer makes sense. Okay, we're done with example 6. Now I feel like I'm warmed up, stretched out a little bit. Now I can go back to example 5. This one, a solid is formed by joining two hemispheres. So here, oh wow, that looks so good. Two hemispheres, I'm going to do it down here. And it says at the right end of a circular cylinder. So think of a can, but you've got a half a ball on one end and a half a ball on the other side. The total volume of the solid is 12 cubic centimeters. So I've got a constraint of some sort. Find the radius of the cylinder that produces the minimum surface area. There it is, the minimum surface area. This is what I'm taking the derivative of, the surface area. If you want to just call it A, so that you don't get it confused and think you have to do the product rule at some point, this is what you're going to take the derivative of. If I wanted to figure out what is the surface area here, let me just try to find the equation. Maybe it'll be easy. If I find the area, so the first thing is just of this can. If you think about taking off, here I have a bottle. You can see the cylinder part of it. And actually there's a little sticker on here, but if it were around the entire way, what you can tell about this is that actually if I would unwrap the outside of this, I could actually form it into a rectangle. And this rectangle would have this length, whatever it is. What did I call it in the other one? I think this would just be the height of the cylinder, so let's go with that still. Times the width of the rectangle would actually be the distance around a circle. So 2 pi RH. Don't worry if you ever have to do something like this where you're saying, I don't know if I could get this formula, or think about a can and then the outside, like the wrapper becoming a rectangle, or know what this circumference is. That's okay. This would be given to you, but this is just for this part. Then I need to find the surface area of a hemisphere, or of both hemispheres, so one whole sphere. So I'm going to say 2 pi RH plus, and then the other one is just, this would be given to you in some way, that 4 pi r squared is the surface area of a sphere. Now, if I'm like, yes, let's take the derivative, I'm so ready to do calculus. Sad day, because there's an r and an h and an r over here. And so I need to eliminate one of these variables. So this is where the constraints come into play. I know that the total volume of this solid is 12 cubic centimeters. So volume, but this volume is two different shapes together. It is a cylinder, which would be pi r squared times h, plus also this hemisphere. So there's two hemispheres making up a whole sphere, and how I find that would be 4/3 pi r cubed. Okay, get ready. If you have a hat on, hold on to your hat. If you have a horse beside you, hold on to your horses. Horses? You probably only have one horse. Hold on to your horse, because this is where it gets a little bit tricky because of the algebra. You can do it. This is where we've got to come back to really understand what's going on in the problem. If I want a minimum surface area, this is what I want to take the derivative of. This is just going to help me get there. My volume was 12 cubic centimeters. So I substituted in 12 for volume. There's an r squared over here and r cubed here, so what I'm going to do is solve for h actually. So 12 minus 4/3 pi r cubed is equal to pi r squared h. Now I want to isolate h, so divide by pi r squared on both sides. Beautiful. I've got h by itself. This is kind of gross, but it's okay. So what I'm going to do next is I'm going to say, how do I do this? I want to go with what I did before. This one becomes a little bit easier just because I've done this before. If we separate this into two parts, 12 over pi r squared. And then over here, where this is 4/3, pi divided by pi is going to just be 1. R cubed divided by r squared is just r. And again, no way to really know this besides I've done this problem before, and I know it's a little bit easier if we simplify in that way. We've got a 2 pi r, and instead of h, now we're going to write this whole mess. 12 over pi r squared minus 4/3 r. So this was all in place of h. Plus 4 pi r squared Yay, I can take the derivative, but I don't want to yet. I want to simplify this more. So now I've got a, and I'm going to distribute this 2 pi r. When I do that, I've got 12 times 2 pi r. I'm just actually going to write this out so we don't mess anything up. It would be 24 pi r over pi r squared minus 2 times 4/3 would be 8/3. And now I've got pi r squared, because r times r is r squared, multiplying here times pi, plus 4 pi r squared. Keep going a little bit. I'm going to simplify a little bit more. So I haven't done any calculus yet. Don't be so sad about that. Pi divided by pi would just be 1. R over r squared would just be 1r left in the denominator, or I can write it like this, 24r to the negative first power. And I'm writing it like that just because it's a little bit easier to take the derivative in a minute. This doesn't look like what we usually think of as like terms, but they are. They're both pi r squareds. So I have negative 8/3 pi r squared and positive 4 pi r squareds. If I take over on the side somewhere, negative 8/3 plus 4. 4 is the same thing as 12/3. If I add negative 8 plus 12, I get 4/3. So even though this looks crazy, I actually just have 4/3 pi r squared instead of negative 8/3 pi r squared plus 4 pi r squared. Good news. We get to finally do calculus. This is mine. We get to do calculus dance. Woo! Maybe yours is like this. Okay, let's find a prime. Negative 1 times 24 is negative 24. My new exponent is negative 2. 2 times 4/3 is 8/3 pi r. And you might be thinking, why did we do all this? Because we wanted a minimum surface area, which means that we need to find the place where the derivative changes from negative to positive. So I'm looking for where is the derivative 0 or does not exist. So in this one, I'm going to say 0 is equal to, and I'm going to rewrite this, negative 24 over r squared plus 8/3 pi r. And then from there, I'm going to add 24 over r squared is equal to 8/3 pi r. Solving this for r, multiply both sides by r squared, or yeah, r squared is good. So this would be 24 is equal to 8/3 pi r cubed, because I took r times r squared. I can multiply both sides by 3/8. 24 times 3/8. Do I know this one? If I did this times 3/8 times 3/8, yeah, 24 divided by 8 is 3 times 3 is 9 pi r cubed. Divide by pi. I've said 9. That's not what I wanted. And then of course I have that if I take 9 over pi is equal to r cubed, and then I take the cube root of both sides, that's what you probably, that probably is your favorite number, that r is equal to the cubed root of 9 over pi. It's probably your basketball number. Now I need to see, does this produce a minimum? So if I wanted a minimum surface area, so area, oh, that's not what I wanted, r. There we go, r. I want the minimum surface area, so I'm looking at the derivative of a. 0 to the cubed root of 9 over pi. Add the cubed root of 9 over pi. We get a 0. And then from the cubed root of 9 over pi to infinity. Cubed root of 9 over pi. I have no idea. I'm busting out my calculator for this. So I'm going to say 9 over pi, and then I'm going to just say to the 1/3 power because I didn't want to search in math to get the cube root. 1.42. Okay, great. So I'm going to pick a number from 0 to 1.42, which would be, by the way, if you were writing this to 3 places after the decimal, it would be 1.420 in this one. But here to here, I'm going to keep it as this exact answer. Picking my favorite number, 1, and I'm going to go back to a prime. I'm going to use this one just because I wrote 24 over a squared. This would be negative 24 plus 8/3 pi. 8/3 pi, I believe that this will still be negative. Yeah, because 8/3 times 1 will be positive, but 8/3 of pi is only going to be like 7 something. Let's check. 8/3 pi. Oh, 8.3, excuse me. Which does not compare to this -24. Over here, if I'm substituting a number, let's substitute in a million, and be really careful if you're going back to this one, because lots of people mess it up with negative. I would urge you to think about it like this. If I have positive 1 million, -24 divided by positive 1 million, this is going to be a super small number, really close to 0. Plus 8/3 times pi times a million, pretty big. This will be positive. So yes, I do have a minimum for A, the surface area of this, and it says find the radius that produces this surface area, which is nice. Then we don't even have to do any more work. This would be the cubed root of 9/pi, and my units would be centimeters. We did it. What's really ridiculous about this problem though, and I feel like I don't even have to tell you, but I owe it to you because you're smart and maybe you did the extra work to get this. If you would go back and find h, you end up getting an h value of 0, which is very sad. So really, if h is 0, you're just talking about a sphere this whole time. Very disappointing. But here's how you do it if there's lots of complicated stuff involved. Let's do more. Have to find it. There it is. Okay, and this one, it says determine the point on this line, y equals 2x plus 3. So that the distance between the line and the point 1, 2 is a minimum. Okay, so I've got something that's a minimum. What's a minimum? In this one, distance is a minimum. If distance is a minimum, that's what I'm taking the derivative of. This is kind of hard to see there. What if I turn on the light? Ooh, that makes it worse for a second. Nope, doesn't make it better. This is the point 1, 2, and you can see that over here. So distance is the minimum. That's when I want to take the derivative of. But if I think about distance, this is not, I wasn't given this formula. You have to go back into your mind and be like, oh, what will be the shortest? Well, the shortest would be wherever I make a 90-degree angle over here, from here to here. And the distance formula is given by using the Pythagorean theorem from a long time ago and solving for d, or you can remember it's like this, the distance formula, where it's the x2 minus x1, do you remember this, squared plus y2 minus y1 squared. The change in x's over the change in y, like this would be, or the distance between the x's, the distance between the y's, x's, y's, this is where it's coming from, and then you're finding whatever the value of c is. Actually, that's not the right exact thing, but you get the idea though. This is the change in the x's, the change in the y's, and you can figure out what is the smallest distance. It's going to be slightly different though, because this is distance here. So I kind of messed up. Ignore my triangle over there because it's not going to be like that, because it's the distance between the x's and between the y's. Okay, and this is why you got to be careful writing in pen. I don't want to take the derivative of that. That looks disgusting. So let's simplify it in some way. First, I know that I've got a point. Here's my point. It's 1, 2. So really what I've got is x minus my x1 value, which is 1, and then y minus my y1 value, which is 2. Okay, so we can start with this because we've actually got a point 1 and 2. Then I want to simplify it a little bit more because right now I have an x and a y, so I can't take the derivative yet. X minus 1 squared plus, I know y is 2x plus 3. I feel like I shouldn't have circled that because in the past we've done this. This is what I'm minimizing. This is what I need to take the derivative of. I was just indicating that y equals 2x plus 3. We already know. Minus 2 squared. Now I can take the derivative, but before you do that, simplify it in some way. So I'm going to say this is x minus 1 squared. I can actually expand this, so this would be x squared minus 1x minus 1x, that's minus 2x plus 1. plus, over here, I've got 2x plus 3 minus 2. So this is the same thing as 2x plus 1, 2x plus 1. This would be 4x squared plus 2x plus 2x plus 1. 4x squared plus 4x plus 1. That's what I can put here. One more step. So very sad if you're crying because you're like, we haven't done any calculus yet. You're right. Here, this is still algebra, but instead of writing square root, I'm going to write 1/2 so that it's easier to take the derivative of. I'm going to combine some terms here. I've got an x squared and a 4x squared. That's 5x squared. Negative 2x at positive 4x would be positive 2x. 1 and 1. We're good. Now we can take the derivative. The derivative of d is d prime. Chain rule. Wow. 1/2. Leave the inside alone. My new exponent is negative 1/2 times the derivative of the inside. So leave the inside alone. Times the derivative of the inside. You would get 10x plus 2, and this is not the correct answer. This is. One more step. If I were to rewrite this, this is a negative 1/2, which would be a positive 1/2 in the denominator. So I'm going to rewrite 5x squared plus 2x, and I change this to a square root instead of a positive 1/2. This 1/2 would be written as 1 over 2, so I'm going to write that here. This is 10x plus 2. So if you want to say, well, this is the same thing as 5x plus 1, you could do that just in the numerator and get rid of that too. Okay, we did all that stuff, and we're not done yet. We need to figure out where is the distance of minimum. So what I need to do is I want to set the numerator equal to 0 and the denominator equal to 0 to find the critical values for this d prime. Or for the function d, which would be where d prime is equal to 0, or the denominator does not exist for d prime. I should say where the derivative does not exist. In this case, it's where the denominator is equal to 0. Okay, in this step, 5x squared plus 2x plus 2 is a parabola, and it's going to be shifted over because there's going to be a translation of some sort, but I'm going up 2. And so there's actually never a place where this is equal to 0. So all I need to look at is this numerator, and then say, which by the way we said was 5x plus 1, 5x squared, because I could divide each of these parts by 2. In the numerator, 5x plus 1, if I set that equal to 0, and I'm going to use some room over here, 5x plus 1 equal to 0. Subtract 1 on both sides, I get 5x is equal to negative 1, x is equal to negative 1/5. And that's okay. So I'm going to say x is equal to negative 1/5. What I need to do then is figure out, is that in fact a minimum? If this is x, and this would be d prime, because distance is what I want to have a minimum. And I'm finding negative 1/5. Before negative 1/5, oh, I'm sorry, negative infinity to negative 1/5, I'll say it that way. And then negative 1/5 to infinity. Choose a number smaller than that, let's say 0. If I put in 0 in for x, and I'm going to go to this one. If I put in 0 for x, this denominator, I said, oh, you can't see it, there we go. I'm going to go to this one. If I put in 0 for x, the denominator is still going to be positive. The numerator is still going to be positive. Positive divided by positive is positive. Oh no, something happened. Let me check. I can't put in 0. I need to pick something less than negative 1/5. Let's keep going. But now I already did it over here. This would be positive. Let's put in something less than 0. Negative 50. 5 times negative 50 plus 1 is going to be negative. The denominator is still going to be positive. Whew, we fixed it. Obviously, I can't put in 0. I did that wrong first because it's not between negative infinity to negative 1/5. 0 would work over here, which is why we already knew this was positive. That means D is at a minimum. We're good. Now it just says determine the point. Well, we know the x value was negative 1/5. To determine the y value, we know y is equal to 2x plus 3. So 2 times negative 1/5 plus 3 would be negative 2/5 plus 3, also known as negative 2/5 plus, would that be 15/5 equals negative 13/5. We did it! We found the point that would produce the minimum distance. Just to recap, how we would do that is we need to determine the formula for distance. In this case, we used the distance formula, so some equation. We needed to fill in constraints to make this so that the variable, there was only one variable within this problem. So I could find the derivative with respect to x in this case, and I didn't have to do any crazy related rates problems. And then I found to make sure this was the minimum, answer their question. Woo! Last question. A rectangle ABCD with sides parallel and the coordinate axis is inscribed. Inscribed just means stuck inside and the corners are on that parabola. Enclosed by this graph of y equals negative 4x squared plus 4. Find the x and y coordinates to the point C so that the area of the rectangle is a maximum. Okay, this is what we want to make maximum. Area is length times width. But in this problem, if we're finding coordinates and we've already got an x and a y, we need to use those somehow. I can see that the distance, like this point right now, is at the point xy. Over here, this would be negative x, positive y. No, we can do this. If I'm thinking about what is the distance, and I know from here to here is a distance of x, that means from here to here on the other side is also a distance of x. So this is 2x. This kind of looks like somebody who's dead that has a little hat on, by the way. Now you can't unsee it. This is a weird looking nose. So I've got 2x is my width. Then my height, instead of saying h, is y. So this area is 2x times y. I want the area to be at a maximum. Area is a thing I want to take the derivative of, but I can't yet because there's an x and a y. So let's fill something in. Area is equal to 2x instead of y. You can write this up here, the negative 4x squared plus 4. Simplified a little bit, so it's just easier to do the derivative. Negative x cubed plus 8x. Now I can take the derivative, or you can, either one. A prime would be negative 24x squared plus 8. Set this equal to 0 so I can find the zeros. I would get 24x squared is equal to 8 if I add 24x squared on both sides. Divide by 24. 8 over 24 is the same thing as, so I'm actually going to do this over on the side. 8 over 24, if I reduce this, would be 1 over 3. Take the square root. In this one, I can see right now that x is a positive coordinate, so I don't have to worry about positive or negative here. I can just set up my chart with this is x, this is a, and I'm really hoping this is the value because this is the only one I see. This would be a prime, I'm sorry. From 0 to the square root of 1 over 3. Square root of 1 over 3. Square root of 1 over 3 to infinity. Then I check into a prime. I pick my favorite number. I don't know. This is 0 to 1 over 3. What is the square root of 1? The square root of 1/3 would be 1 divided by, I don't know. I'm pretty tired. 0.577. So we can put in 1/2 here. If we put in 1/2 and we go back up to this, negative 24 times 1/2 squared plus 8 is going to be positive 2. So we can say positive. If I pick some other huge number, let's say 5 million, 5 million squared, that's going to be really big, times negative 24, really, really negative, plus 8 is still negative. There's going to be a maximum for a at the square root of 1 over 3. Make sure that I answer the question. Find the x and y coordinates for point C. So I can see point C is positive, square root of 1/3. To find my y value, y was up here, y was negative 4 x squared plus 4. I know x was the square root of 1 over 3, which means I can multiply and say this would be -4. Square root and squares cancel out. There we go. That would be times 1/3 plus 4, -4/3 plus 4. -4/3 plus 4 would be the same thing as -4/3 plus 12 over 3. Final answer. Oh, I'm running off the page. We did it. Thank you for working. I appreciate you. As always, please let me know what questions you have and how I can help you. Thanks. I think you're great. Bye.